So we have here Mike, who's the VP of Business Development for Watson. Mike, I would like to get started asking you, for those of us who have been locked in a cave for the past couple of years, what is artificial intelligence?
Sure. I think, as you said, you would have to be locked in a cave for the last few years. I think if you looked back 5 years ago, 6 years ago, 2010, and if you added up the amount of money that VCs were investing in AI globally, it would have been tens of millions of dollars, fairly small, right? In 2014, it was several hundred millions of dollars. In 2015, it was multiple billions of dollars, right? So we've gone from multiple tens of millions of dollars to multiple billions of dollars in 5 years in this space. Last year, we counted almost 3,000 startups in the AI space, right? So
3,000.
3,000. So it's a big word. It means a lot of things, and I think it's important to understand where the technology is, what it can be used for, et cetera. And I think, classically the term AI stands for artificial intelligence, but when you think in terms of businesses that you might want to create and things you might want to do, you have to separate the science from the science fiction, right? We've all seen the movies, we've all seen the Terminator, we've all seen the different movies that have very scary stories about what AI can do. And in fact, the technology today is really more, I would classify it as augmented intelligence versus artificial intelligence. We haven't really seen anything that I would classify as a standalone sentient being. But we are seeing systems be developed now that help humans do tasks and that can start to take over some trivial tasks that humans are doing today. So we're seeing a pretty dramatic evolution in the underlying technology. The technology itself, just to kind of understand the basics and the breakthroughs around this, it's technology that initially can read the language that we speak in, right? So it's moved beyond being able to look at rows and columns and numbers into being able to read and ingest lots of information, massive amounts of information, and then understand that information, begin to correlate that information along with other pieces of information, then have tools that enable you to start to reason over that information and learn from it. So read, understand, reason, and learn. If you think about that as kind of the characteristics of what these new systems are going to be, that's really what the basis is.
And how did we get here? I mean, what were the technologies that allowed AI to get where we is today?
Well, I think it really goes back a long, long way, right? As anyone who's ever studied computer science knows, there was a gentleman by the name of von Neumann in the late 1940s that introduced the concept of the binary architecture that is the basis for all computers today, the zeros and ones that make up all of the computer programs. That became known as the von Neumann architecture, right? And that's the basic architecture of Intel's chips, IBM's chips, the ARM chips, et cetera. But in 1947, von Neumann said that someday computers will be able to answer any question about any subject. And for the next 60 years, no one could figure out how that could be humanly possible, right? And so over 60 years, that problem became known as the open domain deep Q&A problem, right? Any question, any topic, as deep as you want to go. And no one could ever build that. So over the course of decades, the mathematics behind artificial intelligence were studied, a lot of theories were produced, trivial programs were built to start to prove the theories, but we could never build a true system at scale to deal with that problem. And there were two fundamental problems that had to be solved in order to get there. The first fundamental problem was that the machines themselves were not powerful enough to run the programs, right? The algorithms. The algorithms themselves were too complex to run at the speed they would need to run. The second problem is you needed to have a massive amount of digitized information to power the algorithms. So those two preconditions had to be met, right? And we finally reached that point about 10 years ago, where the systems became powerful enough and there was enough digital information available to start to power the algorithms. And researchers started to really look at this. A group of IBM researchers started in 2007 to see if they could solve the open domain deep Q&A problem. It was 27 PhDs, cross-discipline, that kind of locked themselves in a room for a couple of years. You know, we'd throw pizza under the door to keep them going, but just like startups. But they came out and said that they think they had figured out how to do it. But they were worried that no one would believe that they had done it, right? How do you prove that you solved an unsolvable problem? And so they came up with the idea of getting all the best scientists together from around the world. And at this colloquium on artificial intelligence, someone said that if you could build a system that could compete on the game show Jeopardy in the US, which is a Sony-owned game show, that would be an adequate proof that you had solved the problem. So in 2011, we unveiled the system called Watson that played on that game show. And I think and successfully won. For those that haven't seen it, it's if you ever want to have fun watching a computer versus human thing, it's available on YouTube, and it's really kind of interesting to watch the progression. And you can really see during the show how the system learns during the progression of the game and gets smarter at doing it. That game show, I think, will go a long way in history as kind of the moment that artificial intelligence, the winter of artificial intelligence began to thaw, and we started to see new systems get created. And since then, we've just seen a massive increase in excitement from every industry, every profession, startups all over the world. It's a craze going on in how these systems are being evolved. And it's really because we just reached that moment in time where we had powerful enough systems and there was enough information to power the algorithms. That was really kind of the breakthrough.
Interesting. And how did you get involved into all of this?
I, like many people, saw the Jeopardy match on TV. I'm a long-term IBMer. I've been, you would classify me as an intrapreneur inside IBM. I've started up many businesses over a multi-decade career. When I saw the Jeopardy match on TV, I went into the office the next day and said, I have to have that. So I started working with our head of research to become the person that took it out of research and brought it into the commercial world. And the first couple years were very much like a stealth startup, right? We started working with 6 clients, and that was it. 3 in healthcare, 3 in financial services, and we started trying to figure out how the technology that created the game show system could get taken apart and put together in a way that could actually do something useful for business, right? And we found opportunities in some really interesting places, and we learned a lot about what the capabilities of the system were going to be. And we discovered that the real value was to look at professions in industries where the amount of information being produced by the industry or by academia or by humans had surpassed or bypassed the ability of the humans to consume it, right? So there's now more information than we can use. And once you get to that point, you either have to stop producing the information or you have to create tools that can process the information, right? And that's really was kind of the secret of what we discovered, is that if you look for those spots where the amount of information exists that cannot be consumed by people, that's an opportunity, right? And so we started with healthcare, and we started looking at some very deep problems. And these systems are very different. As I described, this idea of reading and understanding and reasoning and learning, that's different than traditional computer programs, right? In traditional computer programs, you write a program, you feed it data, you fix the bugs, and then it gives you the same answer all the time. These new systems will not give you the same answer all the time. The answers are going to continue to change. They're based on probabilities, not certainties, right? So they're non-deterministic. And that requires you to rethink how you would build applications, because for a world that's used to computers always giving you the same answer, you are going to now introduce applications that didn't, right? Most people would assume the computer was broken, right? But what we had to do was convince people that the computer was going to start to work on problems that we couldn't work on in the past. So we started working on cancer. Right, that was not a system, the cancer application was not something you could download from an app store. Right? It was something that was complex, and the system had to be trained the same way a doctor had to be trained. We had to train it on chemistry, on biology. We had to train it on medicine. It basically had to go to med school. Then we had to specialize it on oncology and understanding that. And it was very different than any previous application because the language of doctors and the language of oncologists, they may speak English, but it's a different kind of English than I ever understood, right? So you have to really understand the domain that you're going into and train the system on that domain. And it took 2.5 years to train the initial system and get it up and running, to get it into market, which when I talked to some people, I had a reporter once ask me, it took 2.5 years to build the system. It must be stupid, right? It competed on Jeopardy and it won, but it couldn't do oncology, right? And so I looked at them and I said, well, how long does it take to train an oncologist, right? And they started adding up the years of medical school and internships and residencies and specialization, and it's a decade. Right. And then the second question I asked them is, how long does it take to become a world-class oncologist, where you're one of the very best in the entire world? And they thought about it, and the answer is decades, right? And when it takes decades to get that kind of expertise, the question that the doctors working with us asked is, what if we could train a system that could be trained to the level of expertise that we have at the world-class level? And then we can make that system available to everybody. We could scale expertise, scale knowledge at a way that it had never been scaled before, right? One of the earlier speakers this morning talked about knowledge as the value add, right, that you have in an organization. But what if that knowledge actually is captured in a system that becomes the new baseline for the next generation? The next generation would start where you left off. They wouldn't have to start at the beginning like doctors do today. They could start with the level of research and expertise that were captured in a prior generation. We could start to see step function improvements in healthcare. That was what started to drive us. And so we got very excited about healthcare as a potential use case for the technologies, because no traditional computing technologies could do it. It was a new space. It was a disruptive technology that could revolutionize an entire profession and an entire industry. Many people have written things that said it's going to take away jobs, it's going to be bad for society. There's been some fear-mongering that has gone on. But the reality is there are not enough oncologists in the world today. And there are not enough oncology specialists on the rare cancers in the world today. And people who have those diseases can't go to the places where those specialists are. Right. So what if we could make that level of expertise available to everybody anywhere around the world? Our initial system is now being deployed in Thailand, in India. It's going into China. It's in use in the United States. It's going to be going into Europe soon. And what it's going to do is start to create a consistent level of understanding of a very complex disease. That, we think, is pretty disruptive. Now, I don't expect startups to start jumping into cancer because it cost me a lot of money to build that system. But when you start thinking about the formula that led to that, right. The formula was look for a profession where the amount of information is greater than the ability of the professional to consume it. If you find that spot, and you can find it in every industry because we've gone through, and you can find interesting use cases for that information. And you can start to build applications that can start small and begin to grow. Because what's really neat about these systems is once you train it on the basis of the information, the next thing you teach it is faster. It's kind of like us when we went through school. Each grade we got better at learning. We were able to learn more and more complex stuff as we went through school. The systems will be able to do a similar thing. We can now teach the oncology system, we can teach it a new cancer type in 30 to 60 days. All right? That's kind of the advances that start to go on. So as you start to think about building a business around artificial intelligence and these technologies, the first application is going to take a while because it's different. You're teaching a system, you're not programming a system. So you have to teach a naked system, you have to teach it the basics, just like we did with chemistry and biology and math, et cetera. So you have to teach it the underlying pieces.
So how do I get started, Mike, as an entrepreneur?
Well, one of the key decisions that we made with our technology and has been followed pretty much by everybody in the industry is we recognized that the value of this technology was going to be putting into the hands of entrepreneurs, right? And so the key was, how do you evolve from a system that played a game show, that was a big supercomputer, into a system that started to work on cancer and law and other things, into something that would be available to everybody. And so we started to decompose the system into APIs. We made the APIs available in a developer cloud so that the Watson Developer Cloud could be available to any entrepreneur that wanted to get access to it. And we made the business model for it very simple, very similar to all the other cloud platforms. It's an API model. There's a, when you're building your application, when you commercialize your application, you start paying for the usage of the APIs, right? Much the same way you would with Amazon or Google or any of the others. And so the idea is to make it available, because there's no way that we at IBM can build all the applications that need to be built, because there's millions of opportunities around the use of the technology, and we want to see some of those breakthroughs occur. There's a great story of a university contest that we ran in the US. We had 10 universities compete. It was great universities. It was RPI and Carnegie Mellon and Michigan and Georgia Tech and Stanford and Northwestern, Ohio State. Those are some great big universities, and they competed off with an application they built. And the University of Toronto came in with an application called ROS. Since then, they came in second in the competition, but they've created a company called ROS Law. And they now have their first product in the market around bankruptcy. So they've taught the system bankruptcy law, and they're making it available to law firms all over the country, so that they, instead of having to go read all the books and stay current on all the changes in the legal system and all the changes that are implied by case law, you've got a system that never gets tired of reading all of the laws and all of the case law and becoming the basis for that. And they're working on additional areas of law as they go forward. That was a startup. That was 5 guys in university that came up with that idea, built that system. The reason they came in second is a team at the University of Texas came up with a social services application to help people that were hungry and in trouble get food for their family. So when it came down to solving the problems of the poor and the needy versus lawyers,
you can't beat that.
The needy won the competition, but the lawyers are off and running with the startup right now. So it's a great story of how startups can be built using the capabilities of these kind of systems.
Awesome. And apart from the platform, which is open, as you're mentioning, what sort of talent do I need to hire into my startup in order to make use of it?
Yeah, I think when you think about these systems, there's 3 ingredients to every cognitive system or AI type system that you build. It's really bringing together a large amount of information, data and information, with process knowledge about the domain or the application, and then expertise. And you can't forget the expertise part. It was really those world-class oncologists working with the system, training the system, that were the mentors. They were like a doctor that was in an internship and then a residency. They have senior doctors that help them learn. In many ways, Watson was the apprentice, and the doctors helped teach the system. So you have to have those 3 elements. So when you think about a domain, you think about, can I get the information? Is it available? Right? And then, do I understand the processes or workflow of an industry that could be disrupted? And then, can I get talent that has the expertise to train the system? Those are the three key ingredients. And often they're different people, right? It may be a process expert in straight-through processing for oil platforms, or it may be someone focused on regulatory compliance on a bank that really understands the regulations. The expertise may actually come from lawyers and regulators that know nothing about computers or artificial intelligence. And the information in that case would come from the law, from the governments, much of which is available online and much of which you can get freely.
Right.
Sometimes you have to license content. Content is the lifeblood of any of these systems. So you have to recognize that some content may be free, some may be fee-based, and you have to think about that in constructing your business model. You build the application, but once you have a system trained on the knowledge, the application development's actually pretty easy. It's pretty straightforward application development. The training period becomes important because you're then making sure that it's coming up with reasonable answers to the questions. And it also gives you reinforcement that the system is learning, right? Because it's getting better at answering the questions over time.
How many hours of training do you think is necessary
depends
in
on
order to get a system
it depends
functioning?
on the application. In the early days with Watson, we would work on applications for a year and a half. Now we're seeing things built in a matter of months. So it's now come down to a pretty reasonable level for something that's still pretty new technology. And the technology is getting better. We're providing new APIs that allow you to understand the context of the people that are using it. So we have APIs to help understand the tone of the person that's speaking to the system or the personality of the person that's speaking to the system. Because if you understand the context around a question, you can create a better answer to that question, right? We've started to add visual context around it. So we've added visual APIs so you can start to understand and learn from images. That'll be expanded to video, right? And so we're going to start to see more and more image processing be part of the overall equation. In fact, we're working in the cancer space, we're working with cancer institutions on the ability to take pictures of growths or moles on your arms or body and send them in so that the system can tell you whether you need to go to the doctor or not, right? Whether it's potentially skin cancer, right? And so if we can solve those kind of problems, that becomes important.
Interesting.
Right.
Question here from the audience. Other than healthcare, any real concrete examples of applications?
Sure. Here in Brazil, actually yesterday, Bradesco went live with 3,100 branches of a Q&A system that enables people to get questions about the products and services that the bank provides. Banco do Brasil is also in production with an application here in Brazil. There's a number of startups in Brazil. In fact, I had one of the startups that did wedding planning and wedding dress planning on stage with me in Europe. We flew them to Europe. They were part of an event that I was hosting over there. So,
right?
Yep. And so it was a great, it's a great example of, the big banks and the startup community both getting access to the same technology at the same time. And for the Brazilian entrepreneurs in the audience, you'll be happy to know that Brazilian Portuguese was one of the first languages that we taught Watson to speak.
Is that right?
Right. So it's important. It's a great market. Bradesco worked with us to help get that done. They wanted to bring Watson to Brazil, and that's now available to the startup community here.
Awesome. Can you talk a little bit about the potential for artificial intelligence? How do you see the world changing, our life changing?
Yeah, I think as I look at it, so I'll give you a simple example. I'll use healthcare because everybody everybody is affected by almost everybody knows someone that's had cancer. Everybody knows someone that has diabetes. So I use diabetes as a chronic care solution. We're building a system with Medtronic right now. Medtronic is one of the world's leading medical device manufacturers in diabetes. So they have insulin pumps that actually provide life-saving insulin and meter that insulin into patients. We have a system built that monitors the level of the blood sugars of a diabetic patient, and we can now predict 3 hours before a hypoglycemic event's going to occur.
Wow.
Right? Now that's life-changing, right? Because for people with diabetes, if you have a hypoglycemic event, you have to go to the emergency room. You're going to be very sick. It could affect other organs in your body. You could have organs that shut down. There are many comorbidities that come in. But if you can stop that visit to the ER before it ever occurs, you can actually change the life of those diabetic patients. So that's not something we could do before, right? It's this intersection between big data and IoT and knowledge systems that bring together the capabilities that start to allow us to change behavior of people with chronic diseases so that they can live a better life. That, I think, is pretty fundamental change. Huge. To the extent, as far as impacts on professions, let's talk about flipping an industry, right? I'll use law again, right? Around the world, big law firms usually have an advantage over small law firms.
Sure.
Because they can put more lawyers on a case, they can do more discovery, they can bury the small law firm in the discovery process so they can't even afford to compete on the case. What if we gave a tool to a small law firm that has read all of the law, all of the case law, knows how to connect between the two, and give them a tool that allows them to operate at an efficiency level that the big law firm can't? You've basically just turned an entire economic industry upside down, right? And it fundamentally changes the way that profession operates. We've just launched a system in the United States for teachers. One of the challenges I think all of us recognize, how many people are parents in the room, right? Parents, one of the things we all worry about is what kind of education is my child going to get when they go to school? And for decades, for hundreds, or for centuries, the education level is usually at the median level of the students in the room, right? Because the teachers have to kind of teach to how to get to as many of the students as they can. But there's always those students on the high end and the low end of that are either bored or troubled with the material. So we started to create an advisor, something we call Watson Teacher Advisor, that helps teachers build the best curriculum for each of the types of students they have in their class so that they can not be challenged by that problem. Now, teachers have one of, I think, the hardest jobs in the world, right? They're dealing with 30 or 40 kids in a classroom, kids that are not always well behaved. There's a lot of anxiety that goes on. There's homework. There's a lot of hours that are in this. And they don't really have any place to go for help because the teacher is alone in that classroom. And so what we're doing is we're just providing an online system where the teachers can log on at night and say, I had trouble teaching this lesson today. Is there a different way to do it? Without having to find another teacher to talk to, without having to go to the principal, without having to go to another class, they can just do it in their spare time online in an interactive way where they're just asking questions and getting information back and having a dialogue with the system. That, I think, will become a great resource for teachers, right? So we see these systems starting to impact, even at the early levels, professions that we really haven't impacted much with technology in the past. I mean, teachers and lawyers and doctors, they use spreadsheets and they use word processors and they use email and they keep records for billing, but they didn't really have computer systems that helped them practice their craft, that helped them teach, that helped them practice law, that helped them solve the world's most chronic diseases or help them identify the right treatment for cancer. We now have the ability to do that. And if you look at just about any industry, you can start to find opportunities for this. Simple cases that we see everywhere is any business that has a call center, right? Call centers are very difficult business problems for companies. Right? One of the entrepreneurs just talked about, finding the right people to operate in your call center because that's your customer service. And what if, one of the reasons that call centers are hard is because it's repetitive work. You're having to answer the same question over and over and over again for people calling in, and people get bored and they'll leave. And a lot of the expense in call centers is constantly hiring and training people. So what if you had a system that could handle 40% of the calls, the ones that are repetitive, they're always going to be the same, that people really don't want to work on. You could have a system to handle those. Then the remaining people in the call centers can deal with the complex problems, the ones that are more difficult. Their work could be more fulfilling. They could get paid more because the costs have gone down. So you can start to change the dynamics of even things like call centers using the technology.
Very interesting. And other than a cost per service and the ability of entrepreneurs of breaking in new markets, are there any other aspects that AI are going to change fundamentally the life of an entrepreneur?
One of the things that I think is fascinating is something we call embodied cognition, right? So think about these cognitive systems as surfaced through a robot. You know, I know that gets a little bit towards the science fiction-y stuff I was talking about earlier, but we're actually working with robotics manufacturers now where Watson becomes the Q&A knowledge base on the back end. The robot actually has the eyesight, the hearing, the voice capabilities on the front end, and you can start to create some pretty interesting applications. We've been working with SoftBank in Japan on their Pepper robot, which is a cute little robot about 4 feet tall. It shows emotion. It's really kind of a fun robot to work with. The arms move expressively. It talks like they're Italian. But the system is starting to be used in banks as a host. They think it'll eventually start to be able to do some of the teller functions. It's being used in retail stores. It's being used in the U.S. By Hilton as in a test as a concierge. I mean, if you think about the best hotels in the world and the experience you've had at the best hotels you've ever been to, the concierge is the person that knows the restaurants, knows how to get you a reservation, knows how to get you tickets. They're a knowledge base. Sure. But we all go to a lot of hotels that don't have concierges. So what if you could capture the knowledge of a concierge about a city in a system that could be at every hotel? Huge. That could then help everybody that's staying in that hotel. So that's just an example of how a new format for these systems are going to start to come out. In the U.S. right now, the popular rage is people like to talk to a microphone in their kitchen called Alexa, which is the Amazon device, the Echo device. And if you think about that, that's just a dumb robot. It's just a stationary robot. They're getting used to the idea of talking to information and getting answers back or having it do simple tasks. That's going to continue. And with systems like Watson and other systems that will be developed, the types of things that you can do with those systems and those robots is going to get more and more sophisticated and more complex.
How do you deal with the criticism and the fears surrounding AI?
Yeah, I think you know, from a today viewpoint, I haven't seen any technology that makes me worried about the science fiction-y Terminator scenarios. But it is something that people are worried about. It is something we need to pay attention to. And I think 2 weeks ago, IBM, Google, Facebook, Amazon, and I can't remember the fifth, came together, a lot of the big names that are really doing a lot of work in AI, to start to put together an open forum on ethical use of AI systems and how they get used. Because I think it's an important conversation that needs to be had, but it needs to be done in the open, right? And I think people need to focus in on, especially entrepreneurs, focusing on the good that can be done, right? Because if you really look at industries, you really look at professions, there's a tremendous amount of opportunities out there for these kind of systems. And the technology is now being given to you because of cloud economics, APIs. You can start to leverage these things without having to build your own supercomputer, your own data centers. You can start to leverage them, use them to build your own applications. And as you do that, you're going to create the next big businesses. And there's no reason that those businesses can't start here in Brazil, but then move on to a global scale. Because as the systems continue to learn, they're also learning new languages. Sure. Watson's now speaking 9 different languages, and we can keep teaching it new languages. And it's not simple like old applications where you just change the screens. You actually have to teach the system the language the same way that we learn a language. It has to learn grammar and dictionaries and the meaning of words and phrases, and you have to learn the nuances of language. Because when it's ingesting information in that language, it has to understand the meaning of that. So we keep adding new capabilities, new languages, and new capabilities. So, you know, I think we're at the very beginning. I would think of, 100 years ago, we began the computer revolution, We're at the very beginning of the information revolution right now. We're in year 3, right? And this is going to be the baseline for the whole next generation of systems that are built for businesses, for government, and for consumers. And it's going to be going on for many decades.
Are we running with the machines or against the machines?
My view is that we're running with the machines. We like to think of the applications and the systems as working with Watson,
Right.
not against Watson. Right?
Excellent.
All right.
Mike, has been honored. Learned a lot. I hope everyone liked it. Thank you so much.
Thank you.